Thank you.
Audience working?
Yeah.
Yeah. So maybe first off, who's actually doing microservices now in production? Who's enjoying that? Who thinks microservices is a very bad idea? Why? There are too many. So what we're going to do today is to basically give a different way of doing microservices. So events first, what events first microservice actually is, and what we basically propose with this, what the idea is. We hope to have that clear at the end of the presentation. I think Pavel already did a short introduction. So we both work for Cibia. It's a consultancy firm in the Netherlands, not only specifically focusing on software development, but also on infrastructure, agile, the whole range basically. But we're also doing a lot of microservice implementations internally, and this potentially is a way. This is a way we're currently already doing it at some of our customers, but it could be the foundation or framework to do well at multiple customers. So first off, microservices. Like we stated, well, I think a lot of people here are potentially already doing it or interested in it or not interested in it anymore. I think it's a bit of a buzzword. I mean, when was it coined? How long ago?
Five,
six years, I guess. Now we have microservices, self-contained services, not about size, about whatever. The thing is basically what you see with microservices and a lot of implementations is that we always try to search for a new shiny thing to fix our problems. And what you normally see is that instead of actually complementing the problems we have, we're just enforcing our current problems into microservices. Actually, yeah, there's some additional people. So if you look at the reactive manifesto, who knows the reactive manifesto has seen this diagram before? Sorry? Everyone here, that's good. I mean, it's ReactSphere, right? So you should know the reactive manifesto. So normally what you see with businesses is they have problems. System is too slow, system is crashing, system is not elastic enough. So normally what you see is a lot of our organizations will say, well, we want to try to invest in microservice because we want to have something which is responsive, want to have something which is resilient, want to have something which is elastic. So they just look at these points and say, well, we're just going to do microservice now, we're going to take the deep dive and go to implement it. So what you see is that, and by the way, this could be a way in which we're slicing the system. So we have two specific microservices here. We have the order service, we have the shipping service, and now we're going to create behavior on top of those services. Who is currently using REST to communicate between microservices? Nice. So this is the way we should do this, right? I mean, we have one service, order service, we have another service called shipping service, and at some point in time when an order is paid, that's some behavior we have in our business, we want to ship that order. So we're just going to send a command using REST directly towards the shipping service.
Yeah, so, but what happens when the shipping service goes down and you're trying to REST your way towards the shipping domain? You cannot complete your tasks, right? So you're dependent on the other service. It's going to be a symbiote relationship where you're really dependent on one. So this is a thing in communication that Conway in 1967 wrote about. Who knows this about Conway's law? So Conway's law describes how we communicate. An organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Well, it's not actually a law, by the way, but everyone sees it as a law, especially in domain-driven design. So when we're highly dependent on the code base and we're structuring this way, you're forcing also the business to communicate that way. That's what it's actually pronouncing. So when we look at when the shipping team goes down, the order team needs to communicate highly with the shipping team, right? So we're trying to be dependent on each other. So we cannot be autonomy-wise, we cannot do things in the order team anymore. We're highly dependent on it. See it as binding your feet to the other team and just trying to run a marathon. You'll probably fall because you have a rope around your thing. So this is only two services, but if you implement microservices and you have 100 services, you get cascading failures. So now every team is dependent on each other, and we're in a microlit or a spaghetti microservices, as I call it. So what we need is actually boundaries, and
yeah. So what we try to do with microservices is basically to introduce boundaries. We want to have systems which are resilient, want to have systems which are scalable, which are responsive, etc. So if we have, for instance, one service which should communicate with 20 other services using REST interface and basically enrich its own data, then if I want to have a fast request response flow and I have to request to 20 services, I will never be fast. If I want to scale and I have to actually scale in lockstep with 20 other services, scalability will be an issue. If I'm completely dependent, then the resilience will not be there. So instead of if we look at forms or microservices or separating a system into several services, those boundaries will, well, if you say this is a service, we have REST in between, the form is still basically split up. So we have those boundaries in form. But the only problem is that we don't need only those boundaries in form, we also need that in communication patterns and language.
What also happens eventually is that you get back to the full-fledged chain testing in acceptance, right? Because nobody trusts each other to be up, so we're doing a full-fledged chain test. Now you're doing discontinuous delivery. So you're stuck.
Yeah. So in the reactive manifesto, the thing people tend to forget is that actually to have the value of having a very responsive system and to have a form which is resilient and elastic, the only way to do this is to actually have a mean called a message-driven architecture. And this is very important. And is a message-driven architecture enabled to implement it on REST? Yeah, potentially, but it is not the best fit. So besides those boundaries, we also need an architectural pattern which enables us to actually have that autonomy within and over those boundaries. So if you look at most microservice implementations, people say, well, I have a monolith. I want to basically extend into a new system. Well, just pick a framework. Just think, well, these are the slices we have. These are the organizational patterns we have. We should reflect it into our services. And we just run into the rabbit hole and hope that everything is fine and everything is well. The problem is that just that Conway stated, is if we don't change our organization or the way we think about building software, the way, well, systems should communicate, then we will just reflect the mess we have in that monolith, specifically in our microservice architecture.
Yeah, so we're trying to solve the problem technically, while we need to look at the problem from a domain perspective. So who knows domain-driven design? Perfect.
Who is doing microservices but doesn't know what domain-driven design is? Can be honest. Great, thank you.
So who has read the book 15, 16 years ago? Who has read the entire book? Also part 4.
Who pretends to have read the book?
So, the book was like 14, 15 years ago, and with microservices architecture, domain-driven design came a bit back. And domain-driven design is a total approach to software development. So you can have the whole skill to design models. So what the first thing in domain-driven design that everyone talks about is the bounded context, right? Who's heard about the bounded context? So the bounded context is domain-driven design is totally different from the microservices bounded context. Bounded context is a specific boundary for language, complexity, logic, and context. So it's about your model in a bounded way, in language.
It's getting quite soft here because we think about technical things and bounded context is something vague.
Yeah.
We developers don't like fake stuff, but
no. So it's about this. So when you read the book, and you read the blue book, it's mostly structure first, right? The first part talks about aggregation, value objects, entities, and how to design these. We're talking about structure here. The problem with structure is that it weighs you down. Something that has been visualized is hard to unvisualize. Who knows the video online where you have 2 teams, one wearing black shirts, one wearing white shirts, they're throwing balls around like a basketball, and you need to look at the basketball, count how many times the white team does it. Who knows this? Yeah, 80% misses the monkey dancing in that shot. And it's totally, they did a lot of studies here also with radiologists, they don't see this. This is called the observable bias. So if we lock ourselves in the structure first, we'll be in a lockdown in structure.
Yeah, and I think that's also the problem, specifically if you look at the traditional way of organizing an architectural session, say we're going to do DDD, then the dungeon master in your organization, the person who knows everything, every trap, will just pick up the marker and you will just write down a model, and then people will think, yeah, I think this is the right model. Actually stepping away from that structure is very difficult because you invested into it, because you just built your microservice reflecting that UML diagram or whatever. But also the same, it's very difficult to see it in any other way. You will always reflect back onto that model.
Who created a model and implemented it straight away, by the way? who created a UML diagram, a model, and then implemented it without trying to look at other models.
I see one guy nodding.
Yeah. Well, a model is by definition always wrong. So keep that in mind.
Yeah. And if you look at design, it's not what it looks like. So it's not about the form, it's how it works. This potentially has some conflict of interest here of people thinking Apple is not about how it works, but how it looks. But Steve Jobs once said it. Maybe even closer, and I think Russ Miles was quoted yesterday specifically on chaos engineering, but he also was more invested into the events first approach. So also some overlap there. What he stated is that if we are in like the initial phases of design or building systems, it's not about the things that matter. It's not about the database models. It's not about the tables or whatever. It's actually about the things that happen. If you look at the business and you're talking with your stakeholder, you will say, well, somewhere in my table row, this and this, I use this, I used an integer, should be a big int, and now the system is crashing. The stakeholder won't be interested. He will just want to know how the business is working and what the impact will be of that choice on this business. So it's about the things that happen, not about the things. So what's an event? Well, if you look at a dictionary, an event is a thing that happens or takes place, especially one of importance.
And especially in DDD world, it's important for your domain, business domain. So we pronounce not to do structure first anymore. Let's do events first, domain-driven design. So there's this guy called Alberto Brandolini. Who knows Alberto? Alberto says, well, software development is a learning process, working code is a side effect. So I always say that yesterday, within like 10 minutes, I pushed something to production, some code. So coding is not our bottleneck anymore, it's learning. It's not the domain expert's knowledge that gets to production. It's your misunderstanding of that logic that goes to production, and that's where bugs come into place. So what we need to be as software developers, in our opinion, is to be sort of like a Dr. House, because people lie. So if I never actually read a functional design that makes sense. I can make 100 assumptions on it, so I can make 100 bugs in production. That's the thing. We need to be more like an anthropologist or like Dr. House to find out what is it that they really want. Not what they think they want. Who has ever been in a discussion in refinement where they say, yeah, we want this thing that Google has on there. It looks like this. Like, who's ever had this conversation? So they probably don't know what they want, which is perfectly fine. So we need to figure out what behavior do you want. So now we go to this model. Who's seen this before? And the question was actually asked yesterday. Who recognized this? This is called event storming. And event storming is brought up by Alberto Brandolini as a collaborative learning technique. So what it is that you pull in some domain experts, stakeholders, preferably stakeholders, because if your product owner is the stakeholder for the business, then you also have like this telephone thing where I tell him a story and he tells you the story, and then the story is probably incorrect. So you want to have real life stories, the people with real life stories in the room. So all the business, you put them in the room and you give them an orange sticky. And the orange sticky will represent an event that happened for their business, what's relative to for them. And what you ask them is, look, here's this sheet of paper. You write down what you do all day or what the business process is. And for yourself, here's a timeline. Write your stickies in sort of like a structured process. Not structured, just write them down as stickies. So here are people like, and then they start writing, they start putting them up. And when they start putting them up for themselves, I ask them, now you're going to enforce the timeline with each other. Oh, they need to talk. So what you want is get all these siloed people in the business in one room with the developers watching what they do, and now they start explaining what they do. And now the assumptions with the business comes in. So now also problems start to emerge, right? If people start talking to each other for some reason, there's a discussion and problems. So we got these red stickies. So I'm here facilitating this, and I'll say, oh, you have a discussion, this is not clear, red sticky. So now there will be some form of timeline here with events, with business events that's important for them. So eventually, within this conversation, structure starts to emerge within this chaos of events, right? So here are we paying, here are we delivering, etc., etc. So we start grabbing some structure onto this board. And this takes like 2-3 hours in total, and you eventually end up with this, which is pretty much useless for people who haven't been here. You needed to be here. But when you're here, I can rip this off, and even now I can tell you where everything is, because it's in my mind, and everyone was there, and everyone talked about it, and everyone knows what happens. And now I can start seeing important stuff emerging on this map.
Yeah. The important here is that it's a tool to actually talk with your business and to combine the knowledge people have on how a business actually works.
And it's not hard. It's just an orange sticky. It's not like a UML diagram. Nobody knows what the hell is going on, especially business people. What's this arrow? This black arrow. Yeah. Well, these are events. Everyone knows.
So we can just try in doing this. So because maybe this was a bit vague, so let's see if we can just basically do an event storming session. We do this quickly. We're not going to do this everything. So we're going to make some jumps here, but basically to show the process. So somewhere in your business something happens. Order created. That's a business event. You can talk to any stakeholder, no understanding order management. They know what an order created is. Developer understands, business understands. If you look at the flow, you could say, well, maybe this is a business flow. So once an order created, eventually it will be confirmed, it will be paid, it will be picked, it will be shipped, and will be delivered. If you have this conversation with teams, potentially people who are doing order management and shipping management, etc., they will tend to have very, well, strict discussions here. Because if you look at this, order created, order confirmed, and order paid, it's more or less about basically the financial part of orders. And as soon as it's going to be picked, is somebody maybe walking around in a warehouse. And what you see, and we're going to make a jump here, is you have these discussions that you see that basically a boundary starts to emerge here. You could state that, well, we have just an order domain here, and we have a shipment domain here. And somewhat here in between, there's something happening. So without ever looking what's happening here, we're going to separate this. And what's actually important here is what you described with the bounded context. So if we just implement the concept of bounded context here, we can just say, okay, the word order has its own meaning here, and it has its own meaning here. And instead of just writing a canonical model, we will accept that the word order will just, well, be completely bounded. So we want to implement this. This is actually readable. Can the lights maybe be a bit dimmed? Yeah?
Oh.
Nice. So we can just write this down in code. And what Alberto Brunelliti stated is, okay, code is just a side effect. So what we actually want to do here is to show that code can be a side effect of the process we do with modeling together with the business. So here we have the package. Let me see where the pointer is. The order package. And this is basically just describing the order event with the order created, order confirmed, and order paid, and just some JSON format is here, just to describe what is happening from an event level, specifically within this domain. And we can do the same for the shipping API. Like I stated, we're going to accept that we can just reuse the word order there. It's potentially another team building this system, so we shouldn't worry about any collisions there. It's their own language.
And that's the important part about the bounded context in domain-driven design.
Yeah. For instance, if you would have
language.
If you have a canonical model, you're thinking about structure first. You're going to build an order database with all the tables, and somebody wants to make a change to the data model. That ensures if you have a canonical model and say, well, we're all going to use the same word order, it should have all meaning, is that you have to have communication when you make the change with all the teams. Here we just accept that teams can make their own choices internally. So here we have the order event, but we should implement this, right? I mean, nice that we have Scala classes, but how are we actually going to build a system out of that? We're going to use Lagom. And Lagom, the Swedish translation is just right fitting, neither too much nor too little. And this is basically what it does from microservices framework. So it's an opinionated way of building microservices which intentionally constrains what a developer can do. The first time I saw this implementation of Lagom in Java, I was not a fan. I'm more or less Akka fan, and basically they wrote a framework which disables all the freedom I normally have with fixing problems with Akka. But the problem is, we all know is, well, you have developers of multiple skill levels. I mean, normally in an organization, you don't not only have 9s or 10s or 11s. You can actually fix complex problems in Akka. Sometimes you have beginners, juniors, meteors, maybe 6 or 7s in what they know about a framework like that. If you're going to push them towards a specific team building a microservice, you know for sure that there will be issues. So what Lagom basically what they do is they completely constrain you. So eventually software development is more or less about the choices you make from a business and a modeling perspective, not so much from a technical perspective. So what we can do with Lagom is that we can just describe an interface, an order service. We say it's a service. Normally you can define REST interfaces here, but what we're going to do here is that we'll just describe that we're going to expose a topic of order events. And basically writing this in this specific topic name.
So let's say we have order paid and order picked. Now we have the events, but we're missing something here, right? We're missing something that needs to happen reactively. So within event storming, we have, when you go deeper in event storming, you have the thing that's called a policy. And this is really important because this is where language and business comes in. So the business actually says, whenever this order is paid, the order needs to be picked. So that's the simplest implementation of a policy in this case. So now we can do this and we can write this down again, like class order service policy. Yeah, sorry. It will happen a few more times. So we can have an order service policy and say, well, you know, we have order events, subscribe at least once, and whenever an order is paid, we should trigger some side effect here, right?
And basically this is where you subscribe is here. So internally, Lagom will use whatever message broker you have the driver for. So for instance, if you have Kafka, that number of events you will subscribe to will just be emitted to Kafka and specifically on this topic name.
Yes, so now it needs to do something, right? So whenever an order is paid, it needs to do something. And an event is something that happened, not something that you're gonna do. So we introduced the commands, the blue sticky within event storming. So the blue sticky is actually saying, well, we're paying an order, and the outcome of paying an order is order paid, and then whenever an order is paid, we need to pick the order, and the outcome is, well, we order picked. So now you say, well, we're still missing something, right? What's the logic in between here? And now finally we come to structure, the structure of an aggregate in domain-driven design. C, for those who don't know what an aggregate in domain-driven design is, it's just an entity that is consistent within himself. So see, that's an entity. So now finally we can say pay order will be done on the order, and the order decides, well, can I do this? Maybe. If I can do this, then an order is paid. And then whenever time an order is paid, that will happen. So we can go a step further, and probably there will be more commands here, so we can actually go towards the state machine, right? So we have different commands which have different outcomes, and all the logic is within this order. So an order can fail too, an order command. So the create order can fail if you cannot create the order, and then it will just return. So this is event storming.
Yeah.
And now we can implement it.
And if you look at this image, and we are actually at a conference with people interested in Scala and Akka, etc., you potentially see something familiar happening here. So internally, how this is modeled is just by using an Akka actor. So what you just stated, I mean, an aggregate is something which contains states, it's potentially single-threaded, it's potentially completely bounded. Basically, it's the same as an actor. An actor, you send commands, it can potentially send a reply, changes its internal states, and could eventually just send out events. And maybe out of scope what event sourcing specifically is, but if you have used Akka persistence, you've seen maybe the pattern, is that the state of an actor is basically the accumulation of everything that happened, which is also how a business works. Yep. So the same events as we are basically describing here in the event storming session are actually the events which are being used internally to, well, update the state of the aggregates. And what's using internally is basically the Akka singleton pattern using the entity framework. So if you have multiple order aggregates, they basically just live somewhere within the order domain, they live somewhere in the cluster. That cluster is automatically spread around multiple machines if you're using Akka cluster. So in terms of like the first things we want to have is a responsive system. Well, Akka can be fast enough, it should be fast enough. Lagom already delivers by just using Akka cluster here on a resilient environment, because if a node goes down, another node will just take it up and will resume whatever he was doing. And it's elastic, so if I have some problems with the throughput on my actors, I will just kill my cluster with additional machines, and all will be fine. I think Fabiano actually, Fabiano Fabian, sorry, I just added the O, will actually have a talk specifically on Kubernetes and Akka cluster, how this is scaling. And this is actually internally also what Lagom is doing. So very good extension there.
Yeah, and as a programmer, you don't need to actually meddle with that.
You don't have to worry. So going back to basically this flow we had here, as well, the lights. Thank you. So we can model that, and we can say, well, we just have an order command. I'm prefixing the P here. People haven't asked a question, why? Why are you prefixing the P here? Basically, what we do here is we describe the internal model of the aggregate. You have an API in which you potentially want to expose events, and you want to have events which you're storing. They have a different life cycle, so it's good to separate those. But here we have a create order, which just has reply type done, which is normally just okay. You want to see if the aggregate can actually accept the command yes or no. Or you can eventually, it's not a good habit, but it could be for testing purposes or whatever. You can also do a reply type with any state. So we can also just directly get the information from the aggregate. In the same way, we can just build some persistent events modeling the API we just described. So we have the order created, order confirmed, and order paid. And here are some things happening which is needed to ensure that you can actually read those events from storage engine and can eventually push it to Kafka. And the data we embed in those commands and events is just basically just Scala case classes, like you normally would do with Akka persistence. So looking at an entity, a persistent entity, modeling that aggregates, it looks a bit like an actor in Akka persistence. There are only some changes. First, we just described, okay, what is the command we're accepting here? What is the event we're exposing? What's the internal state? They're currently doing a rewrite towards typed actors, but more or less you get a complete typed environment. They can only accept a certain type of commands and a certain type of events. They're actually restricting you here what you can accept. It should have an initial state. Normally in Akka persistence, you're doing state management yourself. That also has the problem, if you're changing state from a command and not from an event, things can go bad. You do not have any access towards the internal state of this actor. You only have, well, you can only define what the initial state is. Then looking at the command handlers, we just have a command handler here. The API is going to change, by the way. But we have the create order. And what we do with the create order is we just pick the order lines and the shipping information, and then we persist the event, order created, with the order lines and the shipping information. If we see a pay order commands, we just store the order paid with the reference, and we also store additional event, order confirmed. Basically, we could also have maybe two commands, pay order and confirm order, but basically this is our business logic. We just receive these commands, and then the business interested if it's confirmed and paid, well, we just emit those. And if we receive the read-only command of a get order, we just directly reply with the state we currently have. So we're not changing the state here. We do not have any access towards internals here. We don't have any references or whatever we can add it here. So the on event, what we can do here is that basically, whenever the event comes in, the order created or the order paid or order confirmed, then we're changing our internal state as some kind of copy function on a mutable object, which is basically an extension on the initial state. So like you had with the event sourcing thing, basically all the events coming here is doing a fault left eventually on this initial state. So the state of the aggregate at that point is basically the accumulation of things that currently are happening or happened in history. And what we can do with this, you can take over.
Yeah, so this eventually being stored in a repository, right? So what happens is all the events, in this case, which we find important, get stored in a database in the repository, and it will be exposed to the event processor. But every event will have some sort of sequence number in this. It will have a ID type, so like a bank account 1, a bank account 2, and will have a sequence number. The sequence numbers will be written to the event processor, and the event processor can eventually says, well, I've written this sequence number on it.
Yeah.
Right?
Yeah, what's important here is that basically you have here all of the events specifically on the aggregates. So if you want to know what actually happened within that specific aggregate, this is the way you read. But if you want to know everything which is happening for a specific aggregate type or a domain, what is happening within my order domain, basically you can just consume everything here. This is powered by an Akka persistent query. So if you have Akka persistent, you can use persistent queries. It's basically the same. You can also use an offset in a persistence query to read from a specific slice. And what they basically made is an event processor and a read model. They've made an abstraction on top of that to make that much, much easier. So you cannot basically fuck up there.
Yeah, so you have sequence number 12 here, 0 there, and eventually it'll have 12.
Yeah. Lights.
Lights.
Thank you. So we can use that. We had the interface, right, in which we're exposing the topic. We have to implement that. What we can do here is just to say, okay, we have a single stream with an offset. So we're just going to get the offset here. And then we're going to basically read all of the events for a specific aggregate type. In this case, we just want to have the all of the order events. And we're going to basically add the offset here. And why is this important? Is that if at some point Kafka is going down and I cannot write towards my message broker, he will just retry and retry and retry. At some point with Kafka is online again, he will just sync a sequence number he had in his repository with the read model he has on top, or the event processor he has on top. So potentially you have consistency issues here, but you will never have durability issues between the communication pattern you have internally and eventually to your message broker. And what we do here is, well, you do not potentially want to expose all the events. I mean, if you have a user service, you don't want to expose the events in where people set their password. Even a hash password, sending that over your message broker is normally bad form. People won't like that. So in this case, we're just saying, okay, we're going to filter specifically on these events, and we're going to map those internal persistence events back towards a API format, which you're going to expose externally. There are two different things, so you should have mapping there.
And the discussion usually is, yeah, but these are the same, right? This event internally is the same as I expose externally. Yes, but you still want the mapping because the external API won't change much, maybe, but the internal one probably does. So here's your abstraction towards your API.
Yeah. So maybe heading back a bit. So this is basically the thing we're modeling here. We have the order service, the order paid event, which is going on a message broker. And then that order paid event can be consumed to potentially do something within your shipping service.
Yeah. So, but we're still missing one implementation. So if we recap, we just implemented the pay order. On the aggregate order, it sends out an order paid on the message bus, and somewhere here that order needs to be picked. So somewhere needs to be the implementation of the policy. So whenever an order is paid, we need to pick an order. So within event storming and domain-driven design, the policy is actually between boundaries, but implementing in Lagom, we're going to implement that policy on this side. Because this side will say, well, your order, then I need to do this. So now the logic is over there, not here. So this is how it looks. On this side, we'll just have an order service. It subscribes at least once, and now it's going to map async to a former command, right? Which we did with the business.
What's important here, you see a map async. You always have to do some kind of asynchronicity here. But what's important here is in the implementation is actually using the akka streams implementation for Kafka, and it's using a committable offset. So that means that for every successful future, he will just basically write the offset to Kafka. He will say, well, I read this event on this topic, and then I'll go further. If you have a failure here, he's not writing his offset, he will just retry. So if you have any problems communicating with your p-order, I mean, maybe you're communicating, sending that command to a specific aggregate running on a machine, and that machine goes down, you get a failure back because some kind of timeout, then you know for sure that you won't basically, potentially have consistency issues, but you don't have any durability issues. You basically are sure that eventually the side effect of that command will happen.
Yeah. So what you see now is that purposes are reduced from behavior, not from rhetorical or stated goals. And what you see is that every time a business tells us something, code will change. And this is really important. So every time also language changes with the business, change it. It's easy. I just told you, it's one-on-one. So as a programming model, it really is one-on-one with the business, which is really nice to have a discussion instead of having a discussion with the business. Yeah, we didn't implement it this way. What do you exactly mean? To go even further, if I'm a newbie and I step inside this program model, I can read the code, go to an event storming session, and I exactly see what is going on because I read it in the code. I'm seeing this programming model. So to recap, autonomy is reached by implementing policies of behavior instead of commanding behavior. This is how we split up the services, right? So what we're saying is that in this we can treat REST as an anti-pattern for domain-to-domain communication.
Yeah. And the autonomy is reached specifically because, I mean, if that service goes down, the first one, and it still has messages on its topic, I don't really know if the service is down or is just not emitting events anymore. I don't know. Really don't care. If that service has a problem with the message broker, I don't know if he has a problem with the message broker. As soon as I can consume new events from that specific topic, I don't know if the service went down. I don't know if they were refactoring. I don't know if they have any issues because the server just went on fire or that they just went on vacation and forgot to, not do the shutdown function with a delay. I don't know. I don't care. The only problem is that, consistency could be an issue, but I'm not completely tied to whatever is happening there.
And now the business actually inside your domain logic, they're exposing events. That's the only thing they're exposing. And now they can focus on their business problem. They can solve this. And this is the real power of domain-driven design, where problems can be solved within the domain, and it can actually give you a strategic advantage. You can go faster, faster, faster. The events won't change, but I can be faster within my own logic. I can solve my logic better, 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 as long as I keep exposing the events. Policies change, inside structures change, events usually don't change. You will just get new events. That's really important. So an event won't probably change. You just get a new event. And we always have a complete log of everything that happened in the business. That never changes because it happened. Structure changed, events didn't. So as long as events are readable on the topics, the origin is less important. It's something that happened.
Yeah. So in terms of the structure first, if we're just going to accept that we want to model how the business works instead of how it's structured, so more communication behavior over structure, basically we decouple that from the structure. So if you just made a bad decision and you have a lot of coupling between services and think, well, microservice wasn't that good of an idea because we now have the same mess but it's distributed. And this way we're actually basically having the freedom to eventually maybe split that, merge that together, as long as the events stay the same.
Yeah. So event first delivers on a better way of modeling business and the technology while getting the rest for free. And communication with the business is easier now because we're talking about the same thing. We're really solving business problem now. We really, with event storming, you really know what the business does. You're not assuming that much anymore.
So also to recap maybe, we're not doing microservices here specifically because we think that will ensure scalability or resilience or whatever.
We're not talking about line of codes.
We're not talking about line of codes. We're not doing microservices because it's hip and can potentially fix our problems. We're describing a model here, and microservices is basically the effect of having that model.
Yeah, exactly. It's the effect of the business.
Questions?
We got 2 more minutes, so.
So basically the question was, events will change, how will you upcast and downcast in Lagom? Basically it gives you all the tools you want to do. So you can build migration specifically on the JSON deserializers and serializers, but normally when people are actually heading that direction, I ask them one question. Did the business change? And if the business changed, that means that even the process of changing that business is also an event. So the old events are still valid. If you change something in a business structure and say, well, you're going to do something new, then that's just a new event. So you can do upcasting and downcasting, sure. That's important because eventually if you have a command handler for all the historic events, specifically in aggregate, that can hurt. So then upcasting and downcasting are important. But normally, I mean, new fields, just add them as optional, that will work. Then in your aggregate, you should have the ability to read new items. And normally what you see is somebody say, well, we have a new payment reference because we're not only using PayPal, but also using cash, for instance. Then you know you also have to tackle both scenarios. So the new payment reference for cash is just an optional. So upcasting and downcasting can be done, but normally I would question, well, is it really important? Optionals and eventually just emitting new events, naming them differently is potentially a better fix. 1 minute left. Other questions? Yeah, so the question is, what's the best practice to actually ensure that Lagom is being pushed to production? Lagom is just a Akka application with Play eventually. So if you know how to deploy those in Kubernetes, you can just do that. And any other way.
There are plugins that will create Docker instances for you.
Currently, they have Conductor, and Conductor is built on Mesos, not a Kubernetes. But Conductor, if you have machines and you can connect them together, you can directly just send your images, your service towards Conductor, and he will arrange everything. They're currently doing a rewrite to push Conductor off Mesos and eventually on Kubernetes. I don't know how far that is yet, but I expect that to be delivered within half a year or so. But if you look at the current time frames, they're currently pushing on IBM to potentially do that, because IBM is currently working on having Lagom as a service on their cloud, which is a product of the partnership. So if you're not interested in actually managing that yourself, then go to IBM or any other cloud who's doing Kubernetes, because the IBM cloud is just Kubernetes and Kafka there. And then the other way is just how you would deploy an Akka application.
Thank you. That was it for the time.